Our standard here wants us to use the method of completing the square to transform any quadratic equation in x into an equation of the form x minus p squared equals q that has the same solutions. This standard on your ANET test from a couple weeks ago wanted you or required you to complete the square for the equation 4t squared minus 28t equals 6t squared minus 12t plus 26. Remember that in order to complete the square, your square terms and your linear terms need to be moved to one side of the equation, while the constant terms, those that are numbers by themselves, need to be moved to the other side of the equation. So let's go ahead and do that first. Let's take our equation that we have, 4t squared minus 28t equals 6t squared minus 12t plus 26. I'll give you a moment to get that down. And again, we want the square terms and the linear terms to be on one side, and then we want our constant to be moved to the other side of the equation. So because I already have a squared term and a linear term on one side of the equation, and my constant's over here on the other, I'm going to go ahead and move this squared term and this constant term over here with these. So in order to get this squared term and linear term over with these two, I just need to use inverse operations since they're on the opposite sides of the equal sign. So because I have a positive 6t squared, I'm going to subtract 6t squared. And because I have a negative 12t, I need to add 12t. Now remember, to keep an equation the same, if I do something to one side, I've got to do it to the other. So if I subtract 6t to the second here, I also need to subtract it from the t squared term here, minus 6t squared. And if I add 12t on the right side, I've also got to do it over here on the left, and I'm going to add it to the term that has a t plus 12t. So as I do that, 4 minus 6 gives me negative 2 t to the second. Negative 28 plus 12 is negative 16t equals, these two terms canceled out to 0, and I'm just left with a positive 26, which comes down. So I've moved squared term and constant term to the left, and I have my squared term and my linear term to the left, and I have the constant here by itself. So now that we have that done, now the value of a, or our coefficient in front of x squared, needs to equal 1, and that's going to be done by dividing every term by the value of a. So right now I've got negative 2t to the second minus 16t equals 26. And right now a has a value of negative 2. That's what's in front of t squared. So I need this to be a 1, so in order to get it there, I need to divide every term by negative 2, negative 2, negative 2. When I do that, negative 2 over negative 2 cancels out to 1, and I have a t squared. Negative 16 divided by negative 2 becomes positive 8t, and it equals positive 26 divided by negative 2 is negative 13. So now that t squared has a coefficient of 1, I can begin my completing the square process. So remember, when we complete the square, we're looking at our linear term and seeing what number adds to give me 8. And that would be a 4 plus 4. So to get my new constant, I do 4 times 4. I take the product of the number I have here. So 4 times 4 makes a positive 16. And because I did it to the left side of the equation, I also have to take my negative 13 and also add 16 to the right side of the equation. So again, I needed to add in a constant. I found that constant by seeing what number adds to 8 and then multiplying that number to get my constant. And I added that in on both sides of the equation. So we've got t squared plus 8t plus 16 equals, combine my like terms, negative 13 plus 16 makes a positive 3. Now that I have the perfect squared trinomial, we need to turn it into its factored form. We know it's going to be squared. It's going to start with a t, and what number added to 8 and multiplied to 16? A positive 4. So that's what goes in our parentheses. And it's all equal to 3. Now our goal is to solve for t, get t by itself, so we need to, because it's being added by 4 and then squared, we need to get rid of that exponent of 2 first. We undo an exponent by taking the root, square root, of both sides of the equation. Get this up. When I take the square root of t plus 4 squared, the squared goes away and I'm just left with t plus 4 equals, anytime we take the square root of something, we're left with a positive and a negative solution. We're one step away from solving for t. T is right now being added to 4, so I need to get rid of that positive 4 by taking away 4 from both sides. The 4 minus 4 makes 0, so I'm left with t equals, list that number first, it's a negative 4, and then I'm going to add the square root of 3 first. And then my other solution is going to be t equals, again, our negative 4. And then instead of adding, this time we're going to subtract the square root of 3. And there's our solution.